Okay, so in case you didn't know, the Earth's core is supposedly made out of iron, mostly iron. Earth's core consists of huge quantities of iron. Okay. Here in this page, we're addressing this question here, which is a good question. If iron loses its magnetism at high temperatures, how is Earth's core magnetic? Good question. Iron loses its magnetism when it's heated to a few hundred degrees, yet Earth's core, which produces a strong enough magnetic field to hold the planet together, is made of iron. It's so hot, it's in a liquid state. Why then does molten iron in the Earth's core produce a magnetic field? Gee, I wonder. And I have a pretty good idea. Bullshit. When you hold up a magnet near an iron object, these tiny magnets present inside the object align themselves or line up. This is what makes that object magnetic, and any object that behaves like this is in the presence of an external magnetic field called a ferromagnetic material. However, when you heat a ferromagnetic material like iron, things start to change. What happens when you heat a ferromagnetic material? When you heat iron, what you essentially do is supply additional thermal energy to it. This makes the tiny magnets in iron become promoted to high energy states, pointing in the opposite direction with respect to their neighbors. This means that they are less aligned than before, so their combined magnetism reduces. This goes on if you continue to heat an iron until a point it is reached beyond which iron loses its ferromagnetic properties and ceases to be a ferromagnet. Iron stops being ferromagnetic at 770 degrees Celsius or 1,417 degrees Fahrenheit. Again, Earth's core, molten hot liquid iron, yet a magnet at the same time. Okay. So it's pretty evident that iron ceases to be a ferromagnetic material beyond 770 degrees Celsius. However, we also know that Earth's core consists of molten iron, which is so incredibly hot, nearly 6,000 degrees Celsius, that it makes the core as hot as the surface of the sun itself. Not only that, but the molten iron core produces a very strong magnetic field, something that makes Earth a habitable planet. But isn't that contradictory to itself? Well, of course it is. If iron loses its ferromagnetic properties and ceases to be a magnet at a relatively paltry temperature of 770 degrees Celsius, then how does Earth's core, which is primarily made of iron, produce such a strong magnetic field? Good question. Scientists and researchers have put forth a number of hypotheses in a bid to explain how the Earth's magnetic field is generated. But the only one that's considered plausible is a theory known as the dynamo theory, which converts mechanical energy into electrical energy. Yeah, if you knew everything about the Earth's core, then you would be able to understand dynamo theory in no time. Yeah, you just don't understand it, that's all. That's the answer to everything on the globe Earth, isn't it? Well, it doesn't make sense because you just don't understand it. How could molten hot iron be magnetic? Well, it is, you just don't understand it. Oh, wow. Phew. Put it in simple words. Molten iron present in the core doesn't produce a magnetic field. Really? It doesn't? Rather, it produces an electrical current, which in turn produces an electromagnetic effect, which ultimately produces the strong magnetic field of the Earth's core. Oh, okay. I believe it. It's gotta be a globe. Again, there it is. If iron loses its magnetism at high temperatures, how is Earth's core magnetic?